Hi everyone, this presentation goes over Chapter 28 on data management in the third edition of Jacobsen's textbook, Introduction to Health Research Methods, a Practical Guide. In this chapter, you will learn that data entry, data cleaning, and recoding are important preparatory steps for data analysis. Here's an outline of the chapter. Section 28.1 covers data management. Section 28.2 covers codebooks. Section 28.3 goes over data entry. Section 28.4 goes over data cleaning. Section 28.5 goes over data recoding. Section 28.6 covers statistical software programs, and Section 28.7 goes over data security. Section 28.1, Data Management. So in this section, you will learn that the process of data management really includes record keeping before, during, and after a research study. Section 28.2 covers codebooks. A codebook is a guide that is written up for a particular study that describes each variable and specifies how the data are collected and entered into a computer file. So this can be in, say, a Microsoft Word or a PDF format. It could also be in Excel format. It describes how anticipated data problems like missing responses will be handled. And so here you can include any different types of notes that you have or changes maybe that you made to your data based on how the responses were collected. So figure 28.1 goes over some examples of codebook entries. And so this is just one way that you could create a spreadsheet or a table to put all of the responses from your codebook. So you could start it off as a codebook with the question number, the variable name, question, variable type, variable length, and codes as your column headers. And then you can list out each of the questions in a very similar format to this. So you could list number one, then you include the variable name here, which is int date, which is an interview date. Then it has the specific question, the variable type. So here it's a date format versus numeric or a text format. And then it has the variable length and then the specific codes for each. I typically don't require students to use a variable type in their codebook or the variable length because that's just because I don't normally need to specify those in my own studies, but it is good practice to have that information in the actual codebook. And so then it goes through each of some of the different questions that you could ask about, say, age, sex, work, whether or not someone is a student, and some of the different potential responses that could be added in there. I will say, though, for some of these, it doesn't have a number listed for the response. So, for example, for sex, here we just have an M and an F for male and female. And I always recommend including a number because time you want to do some sort of statistical analysis with your data, you have to have a number for it. It's not going to do a logistic regression. It's not going to do a chi-square if you have an M as a result in your statistical software programs. But this is a good way to start it. So section 28.3 goes over data entry. And so data entry can be entered by hand, or it can come through the different types of statistical software. And there are two different types of program. I think these words are used interchangeably, but Jacobsen really differentiates them within the textbook. So a spreadsheet is considered a file that stores data in the cells of a row and column table, and a database is considered a data management system that stores data in tables, and each row represents one record and related records in different tables that could be linked by using, say, a pivot table. So a spreadsheet usually is just one worksheet within the database, but a lot of times these are used interchangeably. So when you're entering data, there is one technique that is often used, and this is called double entry. And this is the method for ensuring the accuracy of the data file by having two or more individuals include the same data into separate computer files, and then compare those files for agreement and then resolve any discrepancies. This is really good for making sure that the internal validity of the data, the internal consistency is there, but it's expensive if you have to pay people and time consuming. And so it's not always used, but sometimes people like to do double entry for a few different responses and not a full data set. Um, Also, if you have computer data, so if it's something where people fill out the survey online or it's in a computer database, you just export the data. And so you don't need double entry, but it is a technique that's still used. Section 28.4 goes over data cleaning. And so I do a lot of data cleaning for any primary data collection studies that I do, and even for secondary research. This is the process of correcting any typographical or other errors in data files. And so this is really important to keep notes on what data have been cleaned or edited during the process. And so I typically have a sheet where it has the main data set, and then within the same Excel database, I will have a separate sheet that includes my notes. So figure 28.2 has some examples of different data cleaning. And so let's say you have a database and here it has the M and the F. And these are your response options for 6. So you have a capital F and a capital M, and then you have a lowercase m, and then you have an N. So if this is manually entered, that lowercase m, if you do a frequency on that, it's going to give you a different response. So it's going to show there are fewer males than are actually in the study. So during the data cleaning process, you would need to change that lowercase m to a capital M. Also, the N response, um, you have to make a decision on what that is. So is that a not applicable response, or because the N is very close to the M on the keyboard, it's right next to each other, more than likely someone just hit the N and not the M. And so you can reasonably assume that that is a male response. The same for this student variable here. There are some other issues here. So if you're trying to decide yes or no, if it's a student, this N here, if that's say a no, and then you have this one underneath it with a space before the N, then that's not going to read it as if it's an N there. So you're going to have to recode that. You're going to have to clean that to make it an N. And then we have an R here. And then this is listed as a 1 here. Now there's 4 listed as missing here, but then here there's only 2. I'm surprised that there's not the 4 at least missing there. But your lowercase y should be the uppercase Y here. And then the R, you have to go and think, okay, well, what could that R be? Well, it's pretty close to the Y, so more than likely that is a Y as well. So section 28.5 goes over data recoding. So a lot of times you will have your data up front and you need to recode it, whether it's combining it with other variables or say taking a continuous variable and creating different categories. So one is a derived variable, and this is a new variable that's created with the existing data analysis in the file. So an example would be if you wanted to create a variable that says someone is an adult or someone is not an adult, but the only thing you have is age. So you could set it up so that adults represent anyone who's 18 or older, and then those who are less than 18, the adult variable would be a no. And typically with a binary response, it's 0 equals no and a 1 equals yes. Now, not only do you derive variables, but you can recode them, and this is generating values for a new variable based on one or more existing columns in the data file. So in a sense, a derived variable is a recoded variable, but here you're taking more than just that one response. You always want to have a backup version of your data file before creating new variables in a new version. And one thing that's very important to do is to never recode the same variable into the same name. So you always want to come up with a new name for the recoded variable. Sometimes it's just the old name with like an underscore new, or say if it's age and it's continuous and you turn it into a categorical variable, then you would put like age underscore cat. It's just, you may decide that it needs to be changed later on, or someone may ask you to change it in a different way later on. So you don't want to have it that same way. Figure 28.3 goes over some examples of recoding. And so this is that example of creating an adult variable. And so if someone's 6 years old, they're not an adult. So the derived variable adult is 0. If they're 29, the adult variable is 1. Because they're an adult. 43, adult is 1, 14, adult is 0, 91, adult is 1, and 50, adult is 1. And then this is some example of coding. This would be used, say, for SAS or SPSS or Stata, which are some statistical software programs. Then here's an example of calculating a variable, and so this would be a derived variable for BMI, so body mass index, which is calculated by using height in inches and weight in pounds. And then you would have to code it to a certain formula that would give you an that would give you the BMI. And then when you have the BMI, then you could also make a further recode of that by saying less than 18.5 BMI is underweight, and then 18.5 to 24.9 is healthy weight, 25 to 29.9 is overweight, and then 30 and over is obese. And so to do that, you use statistical software programs. So section 28.6 goes over statistical software. And so these are used to assist with the coding and analyzing qualitative data or quantitative data. You can use it for quantitative and qualitative data, but typically it's used more for the quantitative side where you have more numbers. And they can run all sorts of common statistical functions. They should be pretty similar when you use different platforms, but sometimes when you get to the more statistical analysis that is complicated, then you may have a little bit different of a formula that is used within the programs. Then section 20.7 goes over data security, and so this is really making sure that health information is protected and making sure that any survey responses remain anonymous, private, secure, confidential. And this is really the process of protecting any files with passwords or other mechanisms for restricting access. So if you have identifying information, you have to make sure that you password protect it. If you have paper records, you want to make sure that those are safely stored. And if you have any sort of signed informed consent statements, they need to be locked and it needs to be kept confidential by law. Access to all computer files containing sensitive information should be password protected and only accessible to those that are on the study protocol. So anyone who has been approved to be on your study can have that information, but you can't just save that information and then let your friend open the file or even a colleague who's not on that research study. It all has to be protected. And if you go through a formal research process and you go through an institutional review board, they will have you outline specific steps for data security. Typically for class projects, you don't have to go to that extent. So that is it on chapter 28 on data management. Thank you for listening.